Let's attempt to determine the shape of these molecules using VSEPR theory. Okay, the rule still remains the same. Draw, count, predict, and ignore. By draw, I mean draw the Lewis structure. By count, I mean count the electron clouds. By predict, I mean predict the electron cloud geometry. And by ignore, I mean ignore the lone pair. So let's start the first one, SF6. So S here has 6 valence electrons, and F has 7 valence electrons times 6. That will give me 42 valence electrons plus 6 will give me a total of 48 valence electrons. So the central atom here is sulfur. Sulfur has a lower electronegativity. So we have sulfur, we have our fluorine, that's a different color. We have our fluorine, we have our fluorine, since we have 6 of them. We have our fluorine here, our fluorine here, our fluorine down here, and our fluorine up here. This is the ideal way of arranging. Now don't make the mistake of doing axial and equatorial position here. That's only applicable to 5 electron clouds. You can check the previous video. I explained everything on that. So this is the ideal way of arranging compounds that have 6 electron clouds. So this is the Lewis structure, although it's not completed. So let's complete that. We have a total of 48 valence electrons. So we have used up 2, 2, 2, 2, 2, 2. That's a total of 12. 12. That's 2 times 6. That's 12. So 48 minus 12 will give me 36. We have 36 valence electrons remaining. Put that down here. The valence electron remaining. So what I can now assign them to these terminal atoms to complete the octet configuration. Okay, that's completed. So I used up 6 electron per atom times 6. That will give me resistance. That will give me 36. Subtract here, you get 0. So this is the Lewis structure. So we completed the first step of drawing it. So let's count the electron clouds. So let's go. Electron clouds where you can find electrons. So let's count. We have 1, we have 2, we have 3, we have 4, we have 5, we have 6. I advise you check the previous videos from. We started with 2 electron clouds, 3, 4, 5, and now 6. The links will be in the group description below. So we have 6 electron clouds. Now, basically, the way this looks like, let me kind of try to give it a sketch. It may not be the best sketch, but let's try out something. Let's say these are my fluid atoms. Okay, so we have one up here, one down here. So let's try to connect that up. It looks something like this. I don't know if it's very, very clear, but it has like 8 faces. So let me try to see if I can fade that out. This is 1. We use different colors. This is 2. This is 3. Go at the back. There's one at the back. Now this is a kind of 3D. Well, so there's one at the back here. I can't really reach it, but I think you get the idea. So 4. That's somewhere at the back over here. Then 4 at the bottom as well. 4 at the bottom. So we have 1, 2, 1 at the back, and 1 beneath. 4. I don't know if you see the diagram. So it is called, since we have 8 sides, call this octahedron. So we say it as an octahedral geometry. Octahedral. A lot of people want to say, since we have 6 terminal atoms, then it should be hexahedral. But this is very wrong, because look at the geometry of this molecule. It has 8 sides, 8 surfaces, like 8 surfaces, 8 sides, not 6 sides. So it's called an octahedral. So the geometry of this molecule, since there is no lone pair, geometry of SF6 is octahedral. Or any molecule that has 6 electron clouds without a lone pair of electron, we have an octahedral geometry. Let's take a look at IF5. For IF5, I have 7 electrons. That's 7 valence electrons. F also has 7 valence electrons times 5. That's 35 plus 7. Give me 42 valence electrons. 42 valence electron. Again, between iodine and fluorine, which one has the lower electronegativity? Obviously, it's iodine. We have iodine having the lower electronegativity here, so it will be a central atom. And we have 5 fluorine atoms, so let's arrange them. Okay, so I've used up how many electrons? I've used up 2, that's 10, so 42 minus 10 will give me 32 valence electrons. So what do I say 32 valence electrons now? I'll assign them to the terminal atoms in order to complete their octet configuration. So I have something like this. So what I'm adding 6 is that there's already 2 already in this one, so 2 plus 6 will give me 8. That's complete. Let's do that to the rest. Okay, so I gave 6 electrons to each atom times 5. I'll be 6 times 5 is 30. So 30 minus 32 here will give me 2 valence electrons. What do I do to this now? I'll assign this to the central atom. Let's assign that to the central atom. Okay. Did that well. Okay, so this is the Lewis structure for IF5. The next instead we should count. So let's count the electron clouds. There's 1 over here, so this is 1, this is 2, this is 3, this is 4, this is 5, and this one formed by this loop here is 6, so that's the electron cloud. So therefore the electron cloud geometry is still octahedral. It's octahedral. This is the electron cloud geometry. Please don't confuse this for the geometry of the molecule. This is just the electron cloud geometry. Okay, now so we've done that. We've predicted the electron cloud geometry to be octahedral. Last thing to do now is to ignore the lone pair. So if you ignore the lone pair, where is the lone pair? That's this one here in red. If I ignore it, I'll see something like, then put that white. I have my, something like this. I have my iodine with white, and I have my fluorine in orange one here. I'm just trying to withdraw this without the lone pair. So something like this, right? So let's try to connect them. Let's try to connect them and see what shape it gives. So it may not really give a best shape. I'm just trying to drive home a point here. So it looks something like this. Oh, if you look at this very well, this is a pyramid. It's a pyramid, and most pyramids are named after the shape of their base. So look at this base here. That is base. The base of this pyramid is what shape? It's a square, right? So this is a square pyramid. So we say the shape of IF5 is square. The square pyramidal. The square pyramidal. That's the shape of IF5. I hope that's clear. For this shape here, I just give it a sketch. So this is square pyramidal. While SF6 is octahedral. But don't forget that the electron cloud geometry of IN5 is octahedral, but the shape of the molecule is what? The square pyramidal. Let's look at the last example where we have ICl4 minus. Again, let's calculate the number of valence electrons so you can draw the Lewis structure. I has 7 valence electrons since it is an halogen. Chlorine also being an halogen also have 7 valence electrons times 4 atoms. To give me 28. 28 plus 7 will give me 35. So since we're having a minus sign, means that it has gained 1 more electron. That will be a total of 36 valence electron. So between iodine and chlorine, which will be the central atom, the one with the lower electronegativity. So iodine is lower than if you draw your periodic table. You have chlorine above and you have iodine below. And we know electronegativity decreases this way. So iodine, obviously, we have a lower electronegativity compared to chlorine. So we have our iodine and we have our chlorine that's in different color, white. We have our chlorine, so we have 4 chlorine atoms, something like this. So I've used up how many electrons? I've used up 2 here, 2 here, 2 here, 2 here. That's 8. Remove 8 from 36. We are going to have 28 valence electrons. What do I do now? I assign the valence electrons to the terminal atoms in order to complete their octet configuration. So let's do that. I'll apply that here, apply here, apply 1 over here, and apply here as well. So I gave each atom 6 electrons, so 6 times 4 will give me 24. Remove 24 from this. 24 from this, we're going to have 4 valence electrons remaining. What do I do now? I assign them to the center atom. So let me put one up here and put one down here. So we have let me do that spell. So we have a lone here, an electron cloud here, and one over here. So this is Lewis structure of ICl minus. Okay, let's put our square braces since it's an ion. We have put a negative sign up there. Okay, so let's count. The next thing we should count, right? Count the electron clouds. So let's count the electron clouds. We have 1, we have 2, we have 3, we have 4, and we have this, that's 5, and this one down here 6. So the electron cloud geometry is octahedral. Why? Because it has 6 electron clouds. What's the geometry of the molecule? What do we do? The last step says we should ignore the lone pair. Let's do just that. So if I ignore the lone pair, what do I have? I have my pyramidal center, that's the one in green. I have my chloride here. I'm just trying to draw this again. My chloride here, something like this. If I draw that up, it looks like a plane shape, like a square or something. So a kind of square. So that means this, everything here are like on the same plane. So each of the chlorine atoms are like on the same plane. So they are on the same plane. You can check out the diagram of this molecule on the internet, so you see a very good representation. So they are on the same plane. So we say that as this is a square. I think it makes sense to call this square plane. It makes sense, a lot of sense to call this square plane. Okay, so the geometry of, not the electron cloud geometry, but the geometry of the molecule itself is square planar. And one thing you should note is that the front angle for octahedral geometry, let me come back to my SF6. The front angle between this F, let me highlight that, between this fluoride and this fluoride is 180 degrees between these two fluorine atoms here. It's just look like that exact position in them 5 electron clouds. Okay, it is 180 degrees. But the bond angle between each fluorine atom now, that's the others. That's the angle here is 90, the angle here is 90, the angle here is 90, 90, 90, 90. So the only one that's 180 is these two fluorines. Like they are axial to each other, but the other fluorides, they are all at angle 90 to each other. So they can ask you a question that the bond angle here is these two fluorine atoms is what is 90. It may not be exactly 90 because of, in this case now, you know that this, like I told you in previous examples, that electron clouds, they show a repulsive force. So that means that this will bend this slightly, so the angle should be less than 90. By ideally somewhere around 90 or approximately 90.